Alrighty, welcome back to Fortran Bootcamp. Like I was saying in the last video, we are now going to use our newfound knowledge of modules to talk about type-bound procedures. So, let's get right into it. We're going to get rid of these, what we had in here before. I'm going to keep the use my mod. Let's declare a user-defined type. So I'm going to declare a type called, let's do square. I like geometry. It's a nice way of doing things. And a square has certain attributes. What does a square have? A square
Equal side lengths.
Square has equal side lengths. We'll call that L. A square has L. And then a square's got an area. And so, yeah, let's just stick with that. So, here in my main program, let's say I want to have a square. So I'm going to say type square my square. And I could come down here and say, well, my square L, the length of it is, let's say 22 units. And then we can say that my square A is equal to my square L squared, okay? And we can do right area my square A, okay? Let's compile that and see what it does. Fortran, again, we have to compile the module as well as our main program. Okay, so it computed an area of 484. That sounds right to me. Okay, but this is kind of annoying because, well, my square, it knows it's a square. We should just be able to tell it, calculate your own area and tell me what it is. Mm-hmm. So we're going to do that. And in this case, and for this, we're going to declare a subroutine called square calc area. Now I'm going to just type some things out and then I'll explain what I'm doing in just a second. Where in out, don't need that, okay. Calculates the area of the square. Okay, so in this case, so this is going to be of type square, and I'll get to why I've said class instead of type in just a second, but for now just think of this as if I had said type. And I'm going to say this A, because again this is a square object, is equal to this L squared, okay? Now, why did I do this class declaration, or this class keyword here rather than saying type? The reason I did that is because I'm going to take this subroutine and I'm going to turn it into a type-bound procedure. So right now this is just a regular old subroutine. Nothing special about it. But if I come in here to my square type and I say contains, and I'm going to say it contains a procedure, and that procedure is called calc area. And that procedure is defined by square calc area. So now what this is doing is this is tying this square calc area to this square type via the name calc area. So I can come in here to my main program and I can just call my square, or I can do call my square calc area, and we should get the same result. Okay? Now, notice what I don't have here. What do I not have here? There's no argument. But square calc area has an argument. So, the beautiful thing about type-bound procedures, and again, so this is all object-oriented programming in Fortran. This is the way to do things. The thing about type-bound procedures is that when you put in this binding, it will now automatically pass the object on which it is called as the first argument to the procedure. So when I call this my square calc area, Fortran knows my square is now the first argument to calc area.
Right, and so you would have to pass in arguments if there's more than one
Yes.
argument there.
Yeah, and we'll get to that. So let's talk about creating an initialization procedure. We know that when we create a square, it would be kind of annoying if every time I had a square, I wanted to say, okay, set the area, or set the side length, and then calculate the area for me.
Mhm.
That'd be kind of silly. So instead, let's create an initialization procedure. I'm going to create another subroutine, and I'm going to call it square init. And the first argument will be this, again, the square that we're dealing with. The second argument will then be our side length, because that's what defines a square. Again, this is class. We'll do square. I guess I should mention real quick. And this gets into a deeper aspect of object-oriented programming called polymorphism that we're not going to talk about in these videos. You can learn about it more elsewhere. But with these type-bound procedures, the type that you're binding the procedure to, you have to use the keyword class instead of type. And that allows you to use that binding for parent and child classes. Again, that's all polymorphism. We're not going to talk about that, but just know when you create type-bound procedures, you have to use the class keyword. Okay? In out, of course, our length is a real, and that's intent in because we don't need to change it. And then what we can do, I'm going to say this initializes square, implicit none. I hate how it always sticks in these spaces, but whatever. So first thing we're going to do is store the side length. So this L is equal to L. And then we're going to calculate the area. And we could just call this calc area. Okay? So now I'm referencing this calc area function in my initialization function.
I have a question.
Yes.
Every time you type this,
Mm-hmm.
is that always going to refer back to square, even within different subroutines of the type?
The way I'm doing it, yes. Now this name is entirely arbitrary.
Okay, that's what.
Fortran doesn't care what you call this. You can call this T, you could call it self, like Python typically does.
Okay.
You could call it flippity-jib, it doesn't care.
Okay.
It's always just the first argument is the object it's being called on, if you've bound the procedure to the type. So let's create that binding procedure, and I'm going to call this one init, and that points to square init. So now, here in my main program, instead of having to set the length myself and call calc area myself, I can just do call my square init and give it the side length that I want, so 22. Whoops. Compile that, run that, we get the same output. But now we've got a much more clean interface here. We're not dealing with the actual member variables of this type anymore. We're letting it handle all of that itself. We're just saying, hey, here's my side length, do what you got to do with it. Okay? And that's really the best way to do it. And then we could come in here and you can create getters and setters, kind of like C++. It's standard practice to create getters and setters. It's a good thing to do in Fortran as well. You don't really have to. In C++, you have you've got your public and your private and your protected. Protected, I think, is what they are. I don't remember. It's been a while since I've done C++. You have different levels of privacy of your member variables. Fortran has that as well, but it's not as much of the standard that you have to include those. It's kind of like well, my perspective is it's kind of like Python, and you just say, I'm trusting you to be smart about this. So, anyway, and using again your intent keywords can save you from getting into a lot of trouble. We can do the same thing with functions. So let's actually create a getter function here real quick just to show you how a type-bound function works. We'll call it get area and square get area. So I'll come down here in my module and I can declare function now square get area. This a class square and my return value is real. And here in the main body, I'll just say a is equal to this a. Okay. So now I've got a function that instead of directly accessing this member variable, I can just call my square get area, and it'll do the same thing.
You don't have to call it.
No, you don't have to call it because it's a function.
Okay, great.
You only use the call keyword with subroutines.
Would it be incorrect to say set a variable within your main that is like, you could say area equals call my square init 22 so that you can use area again and again? I guess I would just be nervous that that I wouldn't be able to access that after just the one time using it.
Access the area variable?
Yeah. So you're calling my square init 22 there on line 9.
Uh-huh.
Would it be incorrect to name that as a variable within main, or is, you see what I'm?
It's like store the area separately in main.
Yeah.
So you really don't need to do that because it's stored as part of my square.
Okay.
And unless we do anything, that's not going to change.
Mm-hmm.
The area of my square is not going to change unless we explicitly set it to something else or we call init again with some other side link. Unless we explicitly change it, it's not going to change.
Okay.
And so it's best practice that if you've got data stored somewhere, just leave it stored there and access it as you need it.
Okay. Cool.
Yeah. Unless you're doing some really kind of hardcore optimization, and you're trying to minimize, stuff like reading from a file. You don't want to read it from a file a whole bunch of times. Read it from the file into your code and then keep it in your code. Things like that. But otherwise, it's best to just leave your data in one place.
Okay.
Okay. Other questions? Okay. That is type-bound procedures. They're very useful. And again, this is how you do object-oriented programming in Fortran, and it's fun.